All right, boys and girls, welcome back to the drive-thru. Special smooth jazz version, post-party. All right, Scott's Macho March is back. Scott's doing more push-ups. Let's go, okay? And he was determined to eat right and get in shape because it's almost the New Year's and it's that time of year. I'm going to be athletic in 2019, Carson. He started keeping track of the number of push-ups, and he graphed them. Of course he did. After 4 days, Scott was certain he would continue this pattern. Yeah, good luck with that. For a few months, oh my gosh, model the number of push-ups Scott will complete on any given day, including the explicit and the recursive. Well, before I get a formula, Carson, what do I need?
First, you need the...
Exactly. I need a T-chart. Yep. Good call. So, on the first day, how many push-ups? Scott could do 3 wimpy push-ups. Second day.
5.
Third day.
7.
Fourth day.
9.
0th day.
You can do 1.
Slope.
2.
Slope is 2.
And this is...
Y-intercept.
Unrealistic. Because you can't... On 0 days, you can't have...
Sure you can. That basically means yesterday he could do 1 push-up. That's what that means. 1 day ago. Okay? So what's the equation? Explicit equation.
2x plus 1.
Okay? What about the recursive?
F of 1 equals 3. F of n equals f. N minus 1 plus 2.
Just a little review to start. Got it?
Yeah.
Scott's Gym is sponsoring a Macho March promotion. The goal of Macho March is to raise money for charity by doing push-ups. Down? I'm down with that. Scott has decided to participate and has sponsors that will donate money to charity if he can do at least 500 push-ups. They will donate another $10 for every push-ups he can do beyond that, for every 100 push-ups he can do. All right. So now he's going to track this total number of push-ups done at any given day in the month. All right, estimate the total number of push-ups that Scott will do in a month if he continues to increase the number of push-ups he does in the pattern shown. Well, how many did you do on the first day, Carson? And about how many days are in a month?
30 to 31.
Okay. How would we figure out how many he would do on day 30?
Well, we don't want to add 2 every time, because that'll just take 0.
Correct.
So let's see how many days we have. So why don't we plug in 30?
For what? Plug in 30 for X, and how many is he going to do? 61 push-ups. Okay? Now, it wants to know how many they did total. How are you going to figure that out? For the whole month. I got a secret. How many did you do on day 1 and day 30 combined? How many did you do on day 2 and day 29 combined? Uh-oh. How many did he have? How many did he do total on day 3 and day 28 combined?
Day 28 he did 57. Wow, 64.
That's right. So we're just going to do 64 times 15. 64 times 10 is 640 plus, plus 64 times 5, 672. 960, is that what it is?
960.
All right, 960 is our estimate, but I can tell you we're all over it. It's right. Okay? Draw the diagram that shows the total number of push-ups that Scott has done in the month at the end of each day. After one day, he did 3 push-ups on the first day, 3 total. On the second day, 5, plus 3 from the next day, 8. Third day, plus 8 from the last one. Fourth day, plus 15. Let's look for a pattern. Shoot, that should be a 5. Sorry. Second difference. So what type of equation is this? This is a quadratic. Okay? Whole thing is about quadratics. So it's going to involve x squared. What is 1 squared? Okay? And it gave us 3. I noticed 3 is 1 less than 4. 8 is 1 less than 9. 15 is 1 less than 16. 24 is 1 less than... Do you see these patterns? I don't really recognize those numbers, but check these numbers out. Look, this is 2 squared, 3 squared, 4 squared, 5 squared. It's not exactly x squared minus 1, because look, x is 1. So it is...
x squared plus. Yeah.
Right? Now, look, I would expect that you'd be able to do that on your own. That's the whole point of these videos. Okay? But you are starting to see the patterns and understand how these quadratic things do apply to regular phenomena that you see in everyday life. Do you believe that? All right, here we go. So we said it was y equals x plus 1 squared minus 1, right? Model the total number of push-ups that Scott has completed on any given day. Oh, including so that's the explicit. The recursive, 1 was 3, 2, I believe was 7. No, it was 2 was 8. 3 was 15. All right, now how can we get the recursive?
Well, we know our 1 is 3.
All right, what do we do? Well, to get f of 2, which was 8, we took the previous number, 3, and we added 2 times 2 plus 1, right? We added 5, which was 2 times 2 plus 1. Here we added 7, which was 2 times 3 plus 1. Here we added 9, 2 times 4 plus 1. So what are we adding every time? Nope, we're adding 2n plus 1. And that is really difficult. But this is what the people that are taking this class that aspire to be computer programmers, they're going to have to figure out how to do this. This is basic programming stuff, okay? All right. Will Scott meet his goal and earn the donation for charity? Well, let's put in 30 for X. Whoops, -1, -1. What's 31 squared? 961? -1. 960 push-ups for the month.
Yep.
Making that money.
Yep.
Okay? All right. So I'm just going to do the beginning of this homework for you guys. Hey, Carson, what's FOIL stand for?
First, outside, inside, last.
Got it? What's X times X?
X squared.
What's X times -7?
X times -7, -7.
What's 5 times X?
5 times X is 5X.
And 5 times -7?
7, -35.
Which of those terms are like terms?
The X, 2, -2X.
Ready?
Yep.
You do it.
X times X is X squared. Then we do outside, so that would be plus 24. Wait, X is squared.
Inside?
And then we would also do, the inside would be 8X.
Very good.
And then the outside last
That's last.
would be,
So that's X squared. Which color's next?
yellow.
No, you can't write in yellow.
Mid green.
Can't see yellow.
Mid green.
All right, next.
So, X times X, X squared. Outside, we look at, that'd be at -4X.
There you go.
And the inside would be -9X.
And last,
Would be
plus
plus 30.
+36. Okay?